Assalamualaikum warahmatullahi wabarakatuh and good afternoon everybody. First of all, welcome back to Makmal Pendamaian Domestik. Okay, then today, so we will continue with experiment number 3. But before that, let me share my screen first. So nothing much different from what we have done in last 2 weeks, but this time around is gonna be the thorough one. I mean the complete ethical wiring associated with your both power and also lighting circuit. Okay, so hopefully you all can see my screen here. All right, this is experiment number 3, entitled ethical wiring installation for ethical supply system belong from kilowatt hour meter to consumer control unit or DB distribution box. Okay, so the aim to familiarize and determine single phase electrical wiring installations, distribution board, and its component in residential building and draw the single line diagram and schematic diagram for the circuit. So this time around, we are going to have a different approach of completing the report. So you have to draw instead of the home plan, just like what you have done in the last 2 weeks. So this time, so we're gonna have the single line diagram, or in short SLD, or schematic diagram for the circuits. So later on I will demo for you on how to complete the drawing. Okay, so some of the adjectives which I believe most likely identical to what you have seen last week. So same goes to the tools and also the material list. And then the theory part again, so we have the electrical supply system, which which is composed of two groups that belong to supplier as well as the consumer. So the supplier in Malaysia, for example, so we have TMB, so the energy supply. So it consists of cut-out unit that consist of neutral link, service fuse, and also the kilowatt hour meter. Right. So what about the consumer? So this is actually a control unit, consists of control unit, which is a particular distribution board comprising an assembly of electrical components for the control and distribution of electrical energy. So principally in domestic premises. So then we have inside this control or consumer part is actually first item like distribution box, DB, or so-called DFB, the distribution fuse box. So what are there in this D box or DB box? So we have the main switch. So we have the RCCB, stands for residual current circuit breaker. So we have the third one is MCB, or miniature circuit breaker. So we do have also the terminal, the neutral terminal, as well the earthing terminal. Right. So this is one of the example of main switch. So you can read yourself the definition of this main switch. For example, for the SPN, this is the for single phase installation, especially at domestic wiring, our house, for example, school building, any government building, private building. So it consists of SPN type of main switch, single pole neutral. Or if we have the three-phase system, so it's supposed to utilize TPN type of main switch, or the triple pole neutral type of MCB, right? So it's very important as it protects circuit from excessive current or short circuit. So it acts as the protection device in order to protect our circuit from any short circuit or the excessive current. Okay, so it limits the current to whatever value we have as the rating. Normally, what we have in the house is actually 60 ataupun 60 ampere. All right. And then next, we move on to the next items, namely the residual current circuit breakers, or namely as RCCB, or in other words, we also refer it as ELCB, the earth leakage circuit breaker. So it works, these two type of circuit breakers, so they work similarly. So it's ensure that the safety ethical appliances user and article. So it can be switched on manually and tripped automatically. So you can simply see somewhere on the surface of the device something like this button. All right, this shape of buttons. We can actually manually switch off to make it or to trip it. So then you can easily actually check whether it is working good or not. All right. So now the next item is MCB, the miniature circuit breaker. So this is again the main component we have for each electrical power distribution, right? Or for N circuit or the other sub circuit. All right. So again, this is for another type of protection. So now we come to the procedure. 4.1. So make sure all lighting and power circuit at home function well. So this is actually a combination between experiment 1 and experiment number 2. Okay. So turn off all lighting switch at the house. So turn off sockets outlet at the house. So what should you do next is, so you need to now turn off the MCB. So this is what we didn't complete or we didn't do last 2 weeks. Okay. So we should start at, for example, step number 4. Okay. I mean, this is new to you. So you have to switch off all MCB on the distribution box. Okay, and then you have to trace out each MCB. Okay, with the current rating 6 ampere or 10 ampere, it can be 16 ampere, 20 ampere or 32 ampere. All right, so you have to turn on or switch on each MCB from one to another. So try to identify and figure out the end circuit supplied by this MCB by performing tests below. So we have basically two types of lighting circuit. Again, lighting and end circuit, which is lighting and also power. So turn on one of the switch and determine which lamp will light up and record the result on the table. Which table? Table 4.1. So again, you have to trace out which MCB is connecting to which type of load, right? Or which number of lamp. Right, and then what should you do is to randomly attach socket tester. Again, you have your article appliances at home, for example, a simple one, bed lamp, for example, lampu tidur yang paling mudah lah, portable ke. So on the socket outlet, so turn on the switch, observe the functionality of the socket outlet and record the result on table 4.1. So again, you have to trace out which MCB, for example, the power circuit MCB goes. All right, so and then you need to turn off the switch. So then turn off switch, repeat step number 7 and step number 8 procedure to determine all end circuit in the house. Okay, this means each unit of MCB over here will go to one particular end circuit. It's either connecting all the lighting circuits or connecting all the power circuit, which consists of outlet circuit. Okay, so from your result, draw and labels the single line diagram for the electrical supply system in the house. So this one I will show you later. I will demo you later. So table 4.1 again. So you have MCB number 1, which consists of 6 ampere rating current, for example. So location of the socket outlet or for the load. Okay. So living room, for example, garage, for example. So number of socket outlet. So number 1, blah blah blah. So it is actually a combination again between your experiment number 1 and experiment number 2. But this time around we have the detail of the number of MCB, all right, as well as the current rating. So questions, answer the question in your discussion. So discuss the purpose of grounding, blah 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 blah. All right. So now I will show you, or I will demo you the SLD, okay, the so-called single line diagram of electrical supply system. Okay, so this is what I have briefed you earlier. So this is the control circuit. This is the part of the. Let me change to laser pointer. Oh, it doesn't respond. What happened? So the control unit over here. So from the supplier part, go up to the DB, right? So again, for the control circuit, so it comes from the beginning of the system, which is the outdoor unit, okay, and end up at the DB, the distribution box. So and then in between distribution box and also our circuit, so our lamp, our outlet socket, for example. So this is called an circuit, right? So belong to supplier in this particular example is the MB, of course, right? So belong to consumer, so our own house over here. So this is what have been done by the technician, for example, or the wiring man, the wireman, etc., etc. Okay. So again, what are there in the TMB part? So we have these two units. Okay, the first unit consists of cut-out unit and also the neutral link. So this is the cut-out unit. Okay, so this is the neutral link. So a cut-out unit is actually to disconnect the circuit. So basically kalau you tak bayar, okay, kalau you tak bayar bill kan, so the bill has overdue for several months, up to 3 months, for example. So there is so there will be some guy or one guy, so technician, so we come over to your house and they just unplug or just simply take out this cut out unit. So this is what they call it, cut out unit. So sometimes people simply say cut out, isn't it? Cut out. It's not cut out, but it's a cut out unit. So this guy will simply take out this unit and everything will be disconnected. So blackout, right? So make sure you pay your bill lah. And then the kW watt hour, so this kWh or kilowatt hour meter, so this is to measure the usage of the electricity in terms of watt hour. Okay. So how much you have consumed the power. And then start from here, so belong to consumer. So we have inside this DB box or the DFB box. So we have first the main switch. So I have shown you some of the example of the actual unit. So 60 ampere is the current rating. SPN stands for, again, the single pole and neutral, so single phase. And then we have the second unit over here. It is actually the earth leakage circuit breaker ataupun ni bahasa Melayu actually PLBB ni. So this is pemutus litar arus bumi, bocor ke bumi, BB bocor ke bumi lah. So the rating, power ampere rating or the current rating is 40 ampere. And then so we move on to this series of MCB. So these are all MCB, the miniature circuit breaker. All right. So the PFA actually this is in bahasa. So this is peti fuse agihan. Okay. Ataupun DFB lah, distribution fuse box. So sequence represent the number of unit. So sequence, so we have way number one, way number two, or unit number two. So we have number 3, you have number 4, so you have number 5 over here, and we have number 6. All right, so 6 ways. One pole and neutral. This is stand for single phase, of course. All right. So and then MCB number 1. So but this is so there is one information left out in this particular drawing, which is the rating of the MCB. So make sure you write over here MCB 6 ampere, for example. All right. So we have the second MCB over here, MCB number 2, for example, or I have already write it here. So don't forget to put the power rating MCB 6 ampere, for example. And then once we move on to the third MCB, so this MCB, okay, the rating is, for example, this is just for example, so 60 ampere. All right. And then so this is the end circuit. So the line represent a line circuit will go to the a group of load. So group number 1 consists of 2 units of 20 watt fluorescent lamp. Okay. So next it is, so the end circuit again connected to the 1 unit of 65 watt ceiling fan and 4 units of 30 watt 6 downlight. All right. So the detail of the power consumption over here, 20 ampere watt, 65 watt or 36 watt. This is actually not compulsory because it's up to you. If you're able to see or to read the power rating of the fluorescent lamp, whatever you have, then you can put. But for downlight, I believe it's very difficult. for you to disassemble and deattach the unit. So it's very dangerous. So it is actually hidden inside this shielding. So you are not able to see the rating, for example. Then leave it blank. Okay, so you need to write the power rating. All right. Same goes to fluorescent lamp or ceiling fan. If you feel it is too dangerous to find the value of the power. All right. So just leave it blank. So you just put the number of unit and then the type of load. All right. So just enough with, for example, 2 times, or here 2 times fluorescent lamp, 2 times or 3 times. Sorry, 3 times fluorescent lamp, 2 times ceiling fan. Blah 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 blah. So put in detail type of load or type of lamp. It is whether the downlight, so fluorescent lamp, so it can be bulb lamp, it can be also LED lamp, etc. etc. Right? Cylinder, is it what call it? Cylinder, something like that. And then we have a 2 times of 13 ampere socket outlet. Okay, so this is intentionally left blank over here. Okay, so you can proceed with your own drawing or with your own data. So here is again the socket, the outlet socket circuit, and then this is spare, etc. etc. So it's spare, that means if you switch on and switch off the MCB, so nothing happen. That means it is not connected to any type of load, just a spare. Okay. And then what about this one? This is actually the size of the cable. So this is again, so you don't need to disassemble your circuit. Okay, just to check the size of the cable. So it's very dangerous. You are not what do you call it, competent enough to do that. So please don't do that. But you can put the information in your drawing by having the theory only. Theory means if you are dealing with lighting circuit, of course you must use the appropriate size. The appropriate size of the proper size of the lighting circuit is actually 1.5 millimeter square. And then once you go to this outlet circuit, for example, end circuit number 3, 4, 5, up to 6. So it consists of 2 times 2.5 mm square PVC type. So this is just for theory only. Okay. So same goes to the DB box circuit. All right. So we have 6 millimeter square PVC type of cable. All right. To interconnect between one unit to another. All this because it carries higher currents. Therefore, you must use the bigger size of cable diameter. All right. So any question?
Um, I have a question, Doctor.
Yes, Elmi.
Um, you say we have to test the socket and circuit with a multimeter. What if we can't do that? Do you have to just guess?
You can put other type of electrical appliances. Just what I told you during the briefing last week or just now. You can use a simple bed lamp, for example. Lampu tidur yang portable ke, whatever you have lah. You can also have your charger, for example, isn't it? Just to show that the outlet socket is working once you switch on the MCB. So I mean, which outlet socket is working once you switch on the MCB?
For the MCB, what current do we put then?
Current?
Yeah, in the data there's current. We have to put the current, right? Kat data
Yeah.
kan MCB
Yeah,
letak
you can see
current.
the rating. Current rating is just a label at the particular unit inside the DB. So whether ELCB, MCB, all right, main switch, you can simply see from the label on the surface of the unit. So it will show you the rating current, 6 ampere, 16 ampere, for example, and then what else? So 40 ampere for the ELCB, so this is very common one lah, and then 60 ampere for the main switch. Right? So you don't
Okay.
need to measure the current. So you need to measure the current. Okay, you just need to switch on and switch off. So it's really
Alright,
simple.
okay.
So Emily can actually switch on and switch out, isn't it? So you don't have to be that competent to switch off or switch on.
Okay,
Even your
Doctor.
younger brother also can do that lah.
Alright. Thank you, Doctor.
But yes, we can, because we want to make sure your safety also. Ada soalan lain? Very simple this one. So you don't need to draw the home plan. Just the SLD.
Doktor nak tanya lah.
Yes, Arif.
Dah tak perlu buat plan lagi kan? Tinggal proceed dengan single line diagram, betul?
Just what I show you just now.
Alright, mantap doktor. Faham sekali. Terima kasih.
Alright. But must be based on the actual load you have in your house lah, of course. The type of load, the power rating. If you have the power rating, you can read or you can see the power rating, then it's better lah. You cannot just leave it. So don't need to write the power rating of the lamp, for example, fan, ceiling fan, the wall fan, etc. etc.
Sir,
Any more questions?
sir.
Yes, Christopher.
So basically, the experimentally we do not need to draw the home plan. We only draw the MCB connected to which outlet socket or lamp. Is it true?
Yes, just draw the SLD, the one I showed you just now. Okay.
All right.
I will
Thank you,
share
sir.
again. I will show the link to this recorded video, and then again you can do some homework lah, or you can do some revision, and you may refer to the drawing I showed you just now.
Okay. Thank you, sir.
Everything is same. Yes.
Doctor, sorry, just
Yeah, it's fine.
disturb you. I wish to ask because for the LED panel floor lamps, it's fine because I still have extras at home, so I can check through the packaging. But for the ceiling fans in my home, they are installed 30 years before, so I have no idea what wattage they are.
You have no idea what? Sorry, again.
I have no idea what wattage my house's ceiling fans are because they're installed in my home almost 30 years ago. I believe.
Yeah. You mean the wattage, the power consumption,
Yeah,
the power rating, isn't it?
yeah.
Yeah. Just do
Is
estimation, and maybe you can find.
Okay.
Yeah, maybe you can find the same type of fan you are using at home, and then you find the data from there.
All right. Sure. Thank
You
you.
can also actually do the calculation because the limit of the current is up to 6 ampere, for example, isn't it?
Yeah.
So it's very direct forward one. You have P equal to IV. So
Okay.
now you have a fixed value of V. So what the value of V?
200.
240. Yes.
Yeah.
So you already know the current value. What is the current value? 6
6.
ampere. Yes.
Okay. All right.
So you know already the V, sorry. You know already the I, for example. And then you have the value of total P. Yes, the total fee for the entire MCB. So entire MCB, one particular MCB consists of 6 ampere just now, isn't it? And then the voltage is fixed 240. Then you can calculate the total P for that particular end circuit. And also that P will distributed to few units of load. So the challenge, so the challenging part is come from that part lah, basically how to actually aggregate ataupun untuk kenal pasti to identify how much is the power from one unit to another. Okay. Just estimate sahaja.
All right. Got it. Thank you, doctor.
Alright. Welcome.
Doktor, lagi satu soalan boleh ke?
Boleh, Zarif?
Dekat dalam eksperimen tu punya contoh, dia tak ada tunjuk single line diagram tu. Kalau boleh nak minta satu lah buat macam reference.
Eksperimen contoh.
Untuk
Tengok video saya, pause.
Okay. Mantap. Thank you.
Tengok video ni, pause. Copy from there. So the thing is the end circuit must from your actual electrical load you have at your home lah. Okay, electrical load again consists of two type of end circuit. So namely the lighting circuit as well as the power circuit. And then it must be according to your own actual load you have house.
So another question.
Yes.
So for the legend, how about the legend? We
Legend,
just label.
Yes.
All right.
Directly label. Yeah. You can also directly label at the drawing. You can also put legend lah. It's up to you. You can put a extra effort to put the legend. Also can, no problem. The basic one I show you just now. This is very basic one. What must you have in the report? The title in
Thank you, sir.
details, or what the legend. For more details, it is up to you. Basic requirement again is what I just show you. So in this video. Simple, eh? Simple. The more you ask, so the more tasks you have to do. Now, no question, eh? So you ask one, and then I ask you to do one. You ask two, I ask you to do two. Because you ask. No question, then just do what I have shown. I'm joking only.
No
Okay?
more question ke,
I think
Doctor?
it's very... Apa dia? Terpulang lah, nak tanya boleh, tak nak tanya boleh. Tapi
No more
basic tu,
question.
basic lukisan tu seperti mana yang saya tunjuk tadi lah. Oh, no more
Alright,
question.
Doctor.
Nak tanya. So going to, yes, don't make sure nanti you jawab lah question tu in your discussion. So along with your discussion, please answer the question. Two simple question lah. The rest tak ada perubahan seperti mana last 2 weeks lah. Make sure you submit dalam outer. But this is only for MPE lab, Makmal Pendayaan Elektrik. So next week is going to be experiment number 4. Makmal, is it Makmal something like Makmal pengujian or Makmal pengukuran? Something like Makmal pengukuran, if I'm not mistaken lah. So conducted by Dr. Iwan. It's either Dr. Iwan, Dr. Hairul, or Dr. Hafiza, if I'm not mistaken. So one of these lecturer will conduct the class and give you the briefing, and then you may ask him or master what should you do for that particular experiment or that particular lab. Okay, which cover again experiment number 4, 5, and 6. And I've told you in the WhatsApp group last week and also in outer. So you must at least know how to use the software Proteus in order to draw the electrical design circuit. Okay, so I believe the instruction is ask you to draw, I believe, a simple circuit, of course, using this Proteus. Okay. I haven't seen the lab sheet yet, but later on your lecture will update lah. So we'll update and we upload in outer as well as WhatsApp group. Okay. Semua jelas? Clear, eh?
Jelas, betul.
Okay, thank you very much.
That's it, Doctor.
So,
Thank
yes,
you.
no,
Okay,
I
okay.
need to stop. All right.
Thank you,
Welcome.
Doctor.
All right, welcome. Good luck, all the best.